So I want to talk today about simplifying radicals. So a radical is just another name for a root, like a square root or a cube root. So this is what it's going to look like. Let's do some vocabulary first. So we have this little symbol, looks kind of like a division symbol. And sometimes there's a little number here in the little crook of it, and then a number underneath. So to read this, when it looks just like this, we would say the nth root of a. So a, that number, that part underneath, is called the radicand. And n is called the index. And if n is 2, we don't write it. Right? So for square roots, we don't write the little 2 in there. But if it's any other index, then we need to write that in there. So when we start simplifying, if the index and the power of a factor in the radicand match. So in this case, right, the index that we didn't write is 2. The power of this factor of a is also 2. So if they're both 2, right, they cancel. So the square root of a squared is a. So it makes more sense when you say it like that, right? The cubed root of a cubed, also a. Fourth root of a to the fourth, a. So if the index and the power match, right, they're inverse functions of one another. They undo each other. And the nth root of a to the n is a. So square rooting and squaring inverse functions undo each other. If the power of a factor in the radicand matches the value or a multiple of the index, then that factor can be simplified. So note, this is only for factors and not for terms. Now, in the examples I have up here, there was just the one number or the one letter in there, so it was both a factor and a term. But I'm going to show you some cases where that's not going to be the case. So here's one example right now. So I have the square root of the quantity 5x squared. So I just have this 5x squared on the inside. It's a whole, it's one big factor. Everybody's multiplying. And I have, the index in the power match. So that equals 5x. But if we look at the square root of x squared plus 25, I don't have any factors in there. I can't factor that to be anything squared. So in order for it to simplify, I have to have just like one thing that's squared or raised to the appropriate power to simplify it. So here I have an x squared, that's nice, but it's also plus this 25. So this x squared is a term and this 25 is a second term. So that doesn't simplify. So this does not simplify. So just to let you know the one that would simplify, if I would have had x plus 5 in parentheses, and then that was squared. So by the way, x plus 5 quantity squared is not x squared plus 25. Remember, there's that 10x that comes with the middle term. But if I have the square root of something squared, these would simplify, and you would just get x plus 5. Okay, so now let's talk about when the power is a multiple of the index. So in this case, I have the square root of x to the 10th. So what I need is I need groups of 2. So if I think about that x to the 10th, right, that's x times itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're just going to kind of show you what it looks like, and then we don't have to do it quite this long again. So, it needs to be a factor. In this case, my index is 2, so I need 2 of the same factor to come out of the radical. So here's a pair, and here's a pair, and here's a pair, right? So I'm just circling the pairs. And then how many pairs do I have, right? So 5. So that means that is x to the 5th outside of the radical. Now, there are a whole bunch of different ways we could talk about that. I also could have written that x to the 10th, so square root of x to the 5th squared, right? Powers to powers you multiply. 5 times 2 is your 10. And now I have the index and the power matching. Also gets you to your x to the 5th. Okay. And then if you know about rational exponents, you could use that as a strategy. So let's go ahead and do our cubed root of b to the 12th. Okay. So write out all your b's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then since it's cubed root, I need 3 of the same factor to come out, right? To be a perfect cube. So circle up your groups of 3. And once I said that, maybe you're thinking, oh, but wait, 3 goes into 12, so I know how many groups I'm going to have, right? So 1, 2, 3, 4 complete groups of 3. So that's going to be a b to the 4th, right? Once it's simplified. So we're going to treat even and odd roots a little bit differently from each other. If the index is an even number, so 2, 4, 6, then the radicand must be positive. And by positive, I really mean non-negative. You can have it be 0. And then, so again, if the index is even, the radicand has to be greater than or equal to 0. And then your root is also greater than or equal to 0. Okay, so even index, everything's positive. Now, if the index is odd, the radicand can be either sign, positive or negative, and the root has the same sign as the radicand. Remember that radicand is the part underneath. So, square root of 49. 49 is positive. Square root of 49, 7. Square root of negative 49, we can't do that one. So we're just going to say does not exist for now. Cubed root of 27. So cubed root 27. So what times what times what? I need 3 factors of the same. So this cubed root of 27 is actually 3. The cubed root of negative 27 is negative 3 because, right, negative 3 times negative 3 times negative 3 is negative 27. So multiplying the same thing by itself 3 times, right, that's something cubed, and the cubed root undoes that. Okay. 4th root of 16. So now I need 4 of the same factor to come out. So maybe you're factoring 16. Let me just kind of show you what that would look like. If you prime factor 16, it looks like that. 2 times 2 times 2 times 2. And so I have 4 and an index of 4. So that answer is just the number 2. But if I do the 4th root of negative 16, that does not exist. Okay. 5th root of 1. You can take the, any index of positive 1 and get positive 1 out. So 4th root, 3rd root, 10th root, anything of 1 is 1. Now, the 5th root of negative 1, this is odd, so then my answer is also negative 1. I can do that. If I have the 5th or the 4th root of negative 1, again, does not exist. So, finally, if the radicand has a variable in it and the index is even, you might need to put absolute value symbols around the variable part of the expression to ensure that it only takes on positive values. Now, I'm not going to spend time on this, but maybe if you're working in an online homework system, you'll have to be aware of that. It only makes a difference if the index is even and you have a variable in there. Okay, so we're just going to practice simplifying. So square root of 36. So you're looking for something that's a perfect square, right? So 36 is equal to 6 squared. Square root squared, square root of 36 is 6. Cubed root of 8, right? Cubed root, 2 cubed, 2. What about the cubed root of negative 8? Negative 2. Okay, square root of x to the 6th. So do you think, can you make a jump from what we were doing up here with our square root of x to the 10th and our cubed root of b to the 12th? Do you think you could write down your answer for the square root of x to the 6th? So x cubed, square root of 100 a to the 4th. Okay. So what could I write? So that's a perfect square. What would it be, right? How would I rewrite 100a to the 4th as something squared? So it's 10a squared squared, so that when these guys cancel, that simplifies to 10a squared. Square root x plus 7 quantity squared. So here, right, here's like that x to the 5 one I did up above. I have some whole quantity and it's squared, and that's under the square root. X plus 7. Fifth root of 32 g to the 10th. So if you're still like, I'm not quite sure, you could go ahead and prime factor everything. Just write out all of the factors, all of the g's. 32 is 2 times itself 5 times. You could write all of those out and then do groupings of 5. So we're doing it 2g squared. Okay. So cubed root of 1,000 is 10. Cubed root of a cubed is a. Cubed root of b to the 15th, b to the 5th, right? That index is just dividing in to those exponents. Oh, here's one of the tricky ones. So square root of x squared plus 4, it's super tempting, right? Because x squared is a square, 4 is a square, but that plus right there says, oh, but wait, these are both terms, not factors, so this does not simplify. X squared plus 10x plus 25. I'm tricking you. Oh my gosh, and we did the x plus 5 up there, so maybe, right? If you look up on your page, you'll say, hey, but wait a second. X squared plus 10x plus 25 factors into x plus 5 quantity squared. So then the square root of something squared, right, just that x plus 5. Square root of negative 121. Index is even. Radicand negative does not exist. Different than it does not simplify, right? This is not a real number. And then 11th root of negative 1. Yep, negative 1.